Weston, Missouri. It's a small town, like a farming town. Weston, Missouri. Oh my goodness, that's crazy. All right. So this is 8.2 continued. You could just continue this where you had those 8.2 notes. So we just need to do 3 examples. We're just going to keep using that quadratic formula. Did you memorize it? Negative b plus or minus. Good. That was good, Carson. All right, so our first example, we're going to give you a function. F of x equals 3x squared minus 6x minus 4. And the instructions are we're going to find all x values. So find all x for which the function f of x equals 0. So we're going to find all the x values that make this function equal 0. So all that means is set this equal to 0. That's all it means. Find all the x values that make it equal 0. We're just going to set it equal to 0. Now we know that if we're solving a quadratic formula and we have it equal to 0, what formula can we use? The quadratic formula. So let's go ahead and let's write down the formula so we remember it. Negative b plus or minus square root of c all over 2a. Good. Negative b plus or minus square root b squared minus 4ac all over 2a. And that's technically x equals that, because that is the x-intercepts. It's what x equals when we solve this, when we set it equal to 0. So what we always want to do is write down off to the side what our a, b, and c are. So what's our a in this function? 3. It's whatever's next to x squared. What's our b? Negative 6. And what's our c? Good, negative 4. So c is always a number by itself, b is always next to x, a is always by x squared. So now we're going to start plugging it in. So we know that x equals, let's see, what should I put for the negative b part? Good, 6, because this means the opposite of b. B is negative 6, so we're going to put positive 6 plus or minus. And then we open up our square root. I would say you can always do this part in your head. What is b squared? What's negative 6 squared? Good, 36. And that'll always be positive. So that's our b squared. And then I always write minus 4. And then you can go ahead and multiply a and c right now in your head and put that in there. So what is a times c? Yeah, 3 times negative 4 is negative 12. And then all of that is over 2 times our a value. So what is 2a? 6. 2 times 3 is 6. Can I cross out this? No. Don't do that. If this was also 6, you could cross out that one and make them both 1. But they have to be able to cross them both out. So now let's figure out what's in that square root. So let's see. Let's just keep everything else the same. 6 plus or minus square root of, well, it's going to be 36. And then is it going to be a plus or a minus? Good. Anytime you see the 2 negatives here, it's going to be a plus. And what's 4 times 12? 48. Good. So that's all over 6. And I know that you're like, I just want to do it all at once in my head and not write any of this down. Well, you'll make mistakes if we do that. So we want to write down step by step. All right, so we've got 6 plus or minus, what's 36 plus 48? 84. Square root 84 over 6. Can I cross out this 6 and this 6? No! But what should we probably check for? Yeah, tree on 84. So we want to check for, can we break this down? So, I don't know, 2 and 42? Does that sound good? That breaks into 2 and 42, and 2 and 21, or or 6 and 7, that works too. And then 21 is 3 and 7. All right, so it's a square root. We're looking for groups of 2. Are there any groups of 2 that get to come out? Yeah, so one group of 2 gets to come out. So this is going to be 6 plus or minus 2 root what? Good, because the 3 and 7 are both left. So 3 times 7 is 21, all over 6. Now there is sort of some crossing out I can do actually now. So we can do heart method here because all 3 of these numbers, this guy, this guy, this guy, and this guy, are all divisible by this one number in common, right? They're all divisible by 2. So we can just divide them all by 2 if you want, or I like to just kind of think of it as heart method. So what's 6 divided by 6? 1. And then we've got the plus or minus. Now when we do this part, we're just going to have to leave the root 21 there. But what is 2/6 simplify to? A third, right? So we can just put root 21 over 3. If you put a 1 in front of that, I wouldn't count it wrong. But that's how we want to leave our answer. X equals 1 plus or minus root 21 over 3. All right, we're done with 1. 2 more. I know that's in my head now. All right, so here is example number 3, continuing from yesterday. We're going to solve x times x plus 5 equals 2 times 2x minus 1. What do you think might be the best thing to do first here to make this look a little simpler? Yeah, let's distribute first. Anytime you can distribute, I probably would do that first if you're trying to solve it. So let's see. Here we've got x times x, x squared. And we've got x times 5, 5x. And then on our other side, let's see, what's 2 times 2x? 4x. And 2 times negative 1? Minus 2. All right, so we've got it a little bit simplified. So as soon as we see that we've got x squareds and x's, what do we want to get it equal to? 0. Good. So, I don't know, I kind of like to have the 0 over here. So I would do minus 4x to get rid of that one. What else could we maybe move in the same step? Yeah, we could get rid of this minus 2 by doing plus 2. That way we'll have 0 on that side. We'll just have to know we need to put a plus 2 on that side too. So let's see. On this side, we've got the x squared doesn't combine with anyone, right? What about 5x minus 4x? Yeah, just 1x, so plus x, and then the plus 2, because he couldn't combine with anyone, because he's just a constant. So plus 2 equals 0, right? Because nothing left there. So what I would always do here is I would check to make sure you can't factor, because if you can factor, that'd be the easiest way to do it. Is there anything that multiplies to 2 and adds to 1? You have to add to 2. No, sorry, multiply to 2, add to 1. No, 2 and 1 are the only numbers, and they don't add up to 1, right? So we're going to have to use quadratic formula, or we could complete the square, but that's going to be a fraction, right? Because you're going to have to divide 1 in half. So I wouldn't do completing the square. I would do quadratic formula. So what's our A? 1. What's our B? 1. Do you guys see where I got 1 and 1 for A and B? Because there's like a 1 right here and a 1 right here. And C is 2. All right, let's do our quadratic formula. So it's negative b plus or minus square root b squared minus 4ac all over 2a. I think it's good to write it out before you even start until you have it memorized. Once you have it memorized, you might not need to write the whole formula out every single time. All right, so let's start plugging this in. What is our negative b? Negative 1, because it's the opposite of b, plus or minus, what's my b squared? 1 minus 4, what's a times c? 2, all over, what's 2a? 2, right? Because we're doing 2 times 1. 2 times a, which is 1, so 2. All right, let's simplify a little more. So we've got negative 1 plus or minus. What's going to be in here? Negative 7. Good, because we got 1 minus 4 times 2, which is 8. So we've got negative 7 in there, all over 2. So maybe we could do a couple simplifying things at once. And actually, if you want to just leave it in one fraction, you can leave it in there. But technically, we're going to have what weird letter in this answer? I. So whenever we have an I, remember we want to write our answer A plus BI. So you kind of want to write it separate. So we can kind of separate it and get that I all in one step. So we can kind of do heart method here. We've got negative 1/2. That's kind of like our A in the A plus BI. And then we've got plus or minus I root 7, right, over 2. So we just want to pull the I out. Sorry, that's x equals. I keep forgetting to write that. X equals this. So when you plug that number in for x, that crazy number, that will make that formula true. Yeah? Okay, you could technically. The problem is if you put would you do it like this? The problem is I just wouldn't do it that way because the people on their test, they always write kind of sloppy and they make it look like it's under the square root. So just to be safe, I always put it in front. You could put it behind though, or to be safe if you wanted to put it behind, I would put it out here like that. Yeah. Mhm. It would be wrong if it was in the square root. Yeah. So I'm gonna make sure I can tell it's outside the square root. All right, we've got one more. Oh, good. You guys have lots of time for your homework. All right. So here's our question: if f of t equals 2 plus 7 over t, and g of t equals 4 over t squared, we want to find all t for which f of t equals g of t. So we're looking for what values of t could we plug in to make those two equations equal each other. So all we want to do on this one, what do you think I should do with these two equations? Liv? Yeah, let's make them equal each other. So we've got 2 plus 7 over t, that's our f of t, equals our g of t, which is 4 over t squared. Okay, so this is a really messy problem with this t and t squared on the bottom of fractions. Does anyone have an idea for what I could do to get that out? We could multiply stuff. We could do math. What can we multiply this guy by to get rid of the t squared down here? Then it would be 16 over t squared. We could do that. We could multiply by negative t squared, and then the t squareds would cancel out. You'd have negative 4 left. Do you want to take anything out of this? Is there one part of that you don't have to multiply by? But you could if you wanted. You don't have to put the negative in there. If we multiply by just t squared, t squared over t squared will go away, right? That's nice. Can I just do that on one side, though? No. So we'd have to multiply this side by t squared too. Do you think that's going to help? Let's see. All right, so what's t squared times 2? 2t squared. Oh, my smartboard's giving out. Letting knows it's almost summer. Okay, now this one's a little tricky. What is t squared times 7 over t? T squared times 7 over t. Some of you guys might have said it, but I'm not sure. I can't hear. Because we can subtract the 2 minus the 1, right? We can subtract our exponents when it's the same base. So it's just 7t. Good. Not 7d, 7t. 7t. So it's just one of the t's canceled on top and bottom. There's one left on top. And that equals, what was left over here? 4. Now that's nice. So we multiplied by like the biggest power of t we saw on bottom, and it got rid of all those t's on bottom. So now I've got this nice equation with t squareds and t's. So what do you think I should get it equal to? 0. So let's subtract 4. Subtract 4. So I'm left with 2t squared plus 7t minus 4 equals 0. If we were going to factor that, does this one factor nicely? Oh, it might. So when I did this in my paper, I used quadratic formula, but I think it might actually factor nicely. If we were going to factor this, what way would we have to factor it? This is a long time ago. AC method, right? Because there's a number in front of the t squared. Let's see. I don't know if it works yet, but let's just see. So we'd have to do 2 times negative 4, right? For a times c. That's negative 8. So remember, we do a times c, and then what do we look for? Multiplies the negative 8 and adds to 7. I think it's gonna work, isn't it? Because we can do 8 and negative 1. Yeah, good. Oh, this is nice. This is gonna be. I see. I think if you can do this, it's better than using quadratic formula. So, do you remember what to do after we find those two numbers? Yeah, we plug them in right here for the 7t. So we rewrite this 2t squared 2t squared plus 8t minus 1t. This is good to review for our final. So we replace the 7t with plus 8t minus 1t, and then we've got the minus 4 equals 0. So you find your numbers that multiply to AC and add to B. You replace the middle number, and then what kind of factoring do we do? Grouping. Good. Man, I'm glad you guys remember this. I love factoring by grouping. Yeah, I think out of those first two terms, we can take out a 2t. So what's left right here? T plus 4. Good. Because 2t times t is 2t squared. 2t times 4 is 8t. What do you guys want to take out of these two then? Ooh, good. Man, you guys are good. And we're left with t plus 4, right? Well, since we know we wanted both of these to be positive, and as it was, both of these were negative, so we want to take out a negative to make it positive. Is that what you're asking? Oh, because we were dividing out a negative, so negative 4 divided by this negative 1 turns into a positive 4. Because you're dividing whatever you put out there. Do you guys remember what to do next? Yeah, we put the 2t minus 1 in a group. That was and then we put the t plus 4 in a group. Man, you guys are good. So remember, we want to get like t equals. So now this is the principle of zero product. What do I do with each of these things? Yeah, we find what makes them equal 0. So what would make 2t minus 1, this, equal 0? A half. And if you weren't sure, you can solve for t. You can do plus 1. So 2t equals 1. 0 plus 1 is 1. Divide by 2. Divide by 2. So t is a half. So there's one of our answers. And what makes t plus 4 equal 0? Yeah. So there's our two answers. So t equals negative 4 and a half. That was nice. I put it, yeah, first instead of smaller. Yeah, we probably should. I'm not going to make you check right now, but you probably should check. Actually, we never squared it. I mean, it's always good to check your answer, but you don't have to on this one. All right, nice. All right, so your homework is page 519, 9 through 42, multiples of 3. Due on Tuesday. You got 4 days. Maybe you can get it done right now.